Good morning, everybody. In this video, we're going to go through and learn about angles and some different relationships they have. The first one we're going to talk about are adjacent angles. Adjacent angles are when we have two angles are adjacent, I would say. So we have two angles are adjacent. If they have a common side and a common vertex. Vertex is just a fancy name for a corner point where they meet. So here I have two angles. I have angle ABC, and I call it ABC because if I go from A to B to C, I draw the outline of that angle. So angle ABC and angle CBD, these are adjacent angles because they share a common side. You can see this wall right here where they're sharing a wall, and they share a common vertex or a point where they meet at. So that's what it means to be adjacent. You're right next to them. You're touching each other. They have a common side right here, side CB, and they have a common point B. So let's look at some other examples down here of what is not an adjacent angle and what is. So right here we have two angles, A and B. These are adjacent angles. You can see they're sharing a wall and they're sharing a point. An example of angles that are not adjacent is this picture right here. And what you can see is that AB is here, and A is right there, and B is here. And while they're sharing a common point right there, they're not sharing a wall together. They're not sharing one wall. And finally, another example of one that's not an adjacent angle is this final one over here. And you can see that, hey, this time they're sharing a wall. Here's angle A, and here's angle B, and they're sharing a wall, but they're not sharing a vertex, like where they all meet. So those would be examples. Our first one was an adjacent angle, and then these two were not adjacent angles. So adjacent angles are nice and easy. They just mean they're right next to each other. So let's look at some more examples. The other thing you want to look at is adjacent angles don't overlap. So like you can see here, they're calling this angle A, this little one. And they're saying angle B would be those two angles that are next to each other added together. And you can see how like angle A is technically a part of this purple angle, angle B. It's like a smaller part of it. Those aren't adjacent because they overlap. So down here it says, which of the following pairs of angles are not adjacent? So let's think of angles that are not adjacent here. So I see if I highlight it, and you don't have to highlight it, I just want you to write down because you have writing all over your board if you highlighted. The angle A and angle C here, they're not adjacent because they don't share a common wall. So let's put our angle symbol, that's the angle symbol, we'll say A, and then we'll say and angle B. Instead of having to write out the word angle every time, you can put this little symbol, this little angle symbol you just saw me draw, and that makes it easier so that way you don't have to write the word angle over and over and over again. All right, let's look at another pair. Another pair we could look at, let's go back to A. I bet we could find one for A. So here's A, and if we look, we could tell that D also is not adjacent because while they share a vertex, they don't share a wall. So let's go back and say angle A and angle D. Oh, and it looks like I did make a mistake here. Earlier on our last problem, I wrote B. I should have wrote C. So make sure you said angle A and angle C. I'm going to go back and just show you why I messed that up. So if you remember when we were watching this video, angle A right here, and we were saying angle C right here don't touch. So I made a mistake there. I wrote B. Make sure you say angle A and angle C didn't touch. They weren't adjacent. Angle A and angle D also didn't. And then the final one that you could say, the last one, I think I see. Maybe you see a few more, but these are ones that definitely stand out. I would say angle B right here is also not adjacent with angle D. And I think that would be our last pair. We would say angle B and angle D. And those are a bunch of pair that aren't adjacent. If you think I'm missing one, let me know. I might have missed one, but I think we got them all. All right, let's go over to the next ones we're going to talk about. The next ones we're going to talk about are supplementary angles. All right, two angles are considered supplementary if you can add them together and they add up to 180 degrees. So right here, you see an example of a supplementary angle. And we have one angle's 40, another angle's 140. Together, if you add them both up, it becomes 180. That's what it's telling us right there. So in this picture, you can see that they're touching. Down here, the angles aren't touching. They're not connected. But as long as the angles add together to equal 180, you could still say they're supplementary. So even though this one is 60 and this one's 120, if I put them together they make 180. And one thing that's always nice is if you have an angle that's 180 degrees, when you put them together, you're always going to have a side that makes a straight line, like down here. They'll always kind of come together, and somewhere they'll make one solid straight line. One way to remember that supplementary is always 180 is that if you write an S, you could kind of turn an S into 180 is how I always think. And I just turn my S into an 8. It becomes 180. It's a fun little way to remember that S is 180. So let's look at an example of two problems. For this problem right here, it says two angles are supplementary and one of them is 31. So this is what these problems are normally going to look like. They're going to give you some type of line. Okay, I'm going to try to draw my best one. So here's my example of supplementary angles. Okay, maybe draw something like that. It says two angles are supplementary and one of them is 31. Okay, so if one of them is 31, they want to know how much is the other one. What would be our x here? Well, there's a couple ways you could do this, but really all we're going to do is we know x and 31 add together, and together they make 180. And if you did that, really all you're doing is subtracting 31 from 180, and whatever's left over we know is what will be for x. So if we did this one, 180 minus 31, feel free to pause the video and try it on your own real quick. But when I type this into my calculator, I see that x is 149, and that would be correct. So make sure we say, hey, these two are 149. Here we have another example. It says two angles are supplementary and one is 127. So when you're looking at these, the main thing you want to do is just look, what type of angle is it and how much is the angle that we have? So it's supplementary. So we know that the angle is going to be 180, and we know one of them is 127 degrees. So if here's my example of two supplementary angles, they make a straight line when they're together. One of them is 127. What's the other one? So once again, remember, these two angles together add up to 180. So I'm just going to write one angle, which is 127, and add it to the other angle, x, and I know together they make 180. And then once again, all I'm going to do is solve the problem. Really, all I'm doing is doing 180 minus 127. And if you go and solve that problem, these cancel out. You get x equals, and then I would type that into my calculator, 180 minus 127, and we get our answer of 53. And we know that works out because if we did 127 plus 53, we know that would add up to 180. So that's how we would do supplementary angles. Those always add up to 180. The next one we're going to do is complementary angles, and it's a very similar style of problem, but two angles are considered complementary. If instead of adding up to 180, they add up to 90-degree angles. So those are what you call right angles. If you have two angles which form a right angle, which is a perfect corner, you can see our example right here. We have two angles, one's 40 and one's 50. Together, they form a perfect right angle, a 90-degree angle. So most of the time, you're going to see them connected, and they'll be adjacent, like the ones we just looked at. But sometimes, like the ones down here, maybe they're not connected. That's okay. As long as when you put them together like a puzzle piece, they add up to 90 degrees, then you know you have complementary angles. And one way you could always remember this is if the C for complementary, you could kind of turn into a 90. And that's a cute little way to remember it if you ever have trouble remembering. I always think that also complementary starts with a C and corner starts with a C, and that's what it kind of makes. So if we look at the problems for this one, if we have a complementary angles, okay, and we'll say one of them 77, what's the other one? What's the one that equals X? Now, one thing you're going to see, one way that always gives away if things are complementary, is you can see I put a little like box in the corner of my angles. That means it adds up to 90 degrees. So if you see that, it's always a dead giveaway. It equals 90 degrees. So I know 177, one is X. Together, they add up to 90. So I'd write down the equation. 77 plus X, just adding those two angles together, and they'll add up to 90. And then all I'm really doing is doing 90 minus 77. And then whatever is left over, I know is left over for that final angle. And if I did that, we'd end up getting X equals, and I believe it is 23, but let me double check. 90 minus 77. Oh, it's actually 13. See, that's why we always double check. And X equals 13. And we know if we added 77 plus 13, we would get 90. Let's do one more. So here, once again, they said two angles are complementary. So we know it has to be a 90-degree angle. That box right there I put in the corner lets us know the whole thing's 90 degrees. One of the angles is 34. So we draw a little line. We'll say this small one is 34, and we don't know the other one, so it's called X. And remember, X is just a number we don't know. So because I didn't know what that angle was, I just said it was X for now. Then once again, we know X and 34, they're going to add up together to equal 90. So I'll add the two angles together, and they'll equal 90. And then all we have to do is subtract 90 minus 34, cancel out these 34s. And whatever's left over, we get to be our X. So we'll cancel this out. And 90 minus 34 gives us 56. And we can say that this angle, X equals 56. And now we have a nice, lovely complementary angle, and we know both of their measurements. All right, the last one we're going to look at is my personal favorite, vertical angles. So vertical angles are angles that are opposite of each other when two lines cross or two lines intersect. And what happens is they end up sharing a point. So you can see I have two lines here at this problem. I have a red line and I have a blue line, and they cross right here in the middle at this point. We do it in black. They cross right here. If you have two lines that cross each other, the angles that are on exact opposite sides of each other will always equal the exact same amount. So vertical angles are always congruent. Congruent's a fancy word for equal. So I'm going to say equal here also so you know what I'm talking about. So what that means is I feel like A was 50, then you know the one on the exact opposite side was 50. And if you know that, you can also then go find out these two angles, but we'll talk about that in a minute. So once again, we have another example here. It says find angles A, B, and C. Okay, so they want me to find the whole thing. So this is really important. So first thing, if I do this, we see I have two lines that cross. I have this line, and I have the other red line, they cross, okay? So I know, first off, that if this angle right here is 40, I know that the one on the exact opposite side, angle B right here, it also must be 40 because it's a vertical angle. So if this one's 40, the one on the opposite side is also 40 degrees because they're vertical angles. But based on what we know of supplementary angles, I could find out what the other measures are. And here's what I want to show you. So if I know that this is 40, all right, I could go ahead and figure out what C and A are because I know an entire circle is 360 degrees, right? If I started here and went all the way around, that's a 360 degrees. So I know that all four of these angles must add up to 360, okay? So if I know that this one's 40 and we know that this one is 40, that means that we've used 80 degrees so far. And if I just did that 360 minus 80, that tells me there's 280 degrees left. That means there's 280 degrees left to split between C and A. So if I just did 280 and I divide it by 2, I'm going to get 140. And that lets me know, hey, C and A are the exact same size. So this one must be 140 and this one must be 140. And we're going to practice that at my table with me in our small group. But that's something that you can always figure out. If you have one angle, if you have two lines crossed, as long as you have one of the angle measurements, you could actually figure out the rest of a circle. And so let's look at our last practice problem we're going to have here. Let's figure out the measure of all these angles. So the first thing I would say is we know that this one's 130, all right? We know right here is 130. And if I know that's 130, I could easily look and say, okay, angle B, you are also 130 because you're vertical angles, all right? So that means I have A and C. Now there's a couple ways I could do this, but what I'm going to do right now is I'm going to add together 130 and 130, and that equals 260. So I know I have 260 degrees between the one they gave me and B. That means whatever's left over is for A and C to split up. So I'll just do 360. That's what our entire circle will equal, minus what we've used so far. We've used 260. And that means that there is 100 degrees that have been unused so far. So if there's 100 degrees that I need to split up between angle A and angle C, I would just do 100 divided by 2. And I know, okay, that means each angle gets 50 degrees, meaning angle A must be 50 degrees. And I know angle C must also equal 50 degrees. And you know that's correct because if you went ahead and you did 130 plus 130 plus 50 plus 50, you would end up with a total of 360 degrees. And that's how it would work out. So those are our notes. Thank you so much for watching. If you have any questions, please make sure you talk to me, and I'll make sure we practice this in a small group together. Talk to you later.